हेलो स्टूडेंट, वेलकम टू माय यूट्यूब चैनल एडू करियर एकेडमी के प्लेटफॉर्म पर स्वागत है। माई सेल्फ डॉक्टर जी। टुडे आई एम गोइंग टू explain in the revision classes of the NCERT of class 10th. The first chapter is the chemical reaction and equations, chapter 1. We are going to revise. Here we can see some condition. Milk is left at room temperature during summers. An iron tawa, pan and nail is left exposed to humid atmosphere, and also we respire a food is cooked. What will happen? What will be occurred in these substances when exposed in the given conditions? So we have already studied about the physical changes and the chemical changes in previous class. In class 9 we have already studied. Changes are the two types. First is the physical change and the second one is the chemical changes. Physical changes are those changes in which if they remove the conditions in which conditions the reaction है performed, then it comes revert back. Means that इन विच कंडीशन, जिस कंडीशन में हम लोग रिएक्शंस कराए होंगे वो रिएक्शन को अगर हम हटा दे और उस कंडीशन को, उस दशा को, टेम्परेचर, प्रेशर या जिस भी कंडीशन में हमने रिएक्शंस कराई हैं उसको अगर हम वापस कर लेंगे तो वो पदार्थ फिर से अपने इट विल कम इन द ओरिजिनल स्टेट, अपनी वे मूल अवस्था में वापस आ जाएगा। तो फिजिकल चेंजेस हियर इन द एक्टिविटी 1. In activity 1 we can see a figure, the burning of magnesium ribbon in air and collection of magnesium oxide in a watch glass. In the figure we can see there is the tongue and the magnesium ribbon means magnesium. What is the symbol of magnesium? Mg. And here at the bottom we can see the watch glass and the setup of the burning. The burner it is used whenever we told about the burning means we are going to provide the reaction without oxygen. मीन्स अगर हम बर्निंग की बात कर रहे हैं, दहन की बात कर रहे हैं, तो वहाँ पे हमेशा क्या वी कैन रिएक्ट विद O2 ऑक्सीजन, तो हम ऑक्सीजन से क्या करेंगे, रिएक्शन कराएंगे। तो मैग्नीशियम react with oxygen, then it becomes the magnesium oxide, the ribbon converted in the powder form. Here we can see in your textbook also you can see at the powder form it will be go in the watch glass which we have put up in the below. Means that magnesium react with oxygen and it is forming the magnesium oxide. This is the burning. Burning is the chemical reactions. Next we are going to study. You must have observed that magnesium ribbon burns with a dazzling white flame. तो वाइट फ्लेम के साथ वो जो है जलती है और चेंज इनटू वाइट पाउडर, सफ़ेद पाउडर में जाती है। पाउडर इज मैग्नीशियम ऑक्साइड ड्यू टू द रिएक्शन between magnesium and the oxygen present in the air it occurred. Next one is the setup of the from the above three activities. This is the activities 2. First we learn the activity. Here is the setup in the formation of hydrogen gas by the action of dilute sulfuric acid in zinc. In this figure here put the zinc granules in a conical. This is the conical flask. In conical flask we have taken the zinc granules, the small particles of the zinc. and here is the cork, and there is a glass tube, we have injected it. And when we react with the dilute sulfuric acid, means that the sulfuric acid which is diluted means mixed with the water, because it will be more concentrated. अगर वो it react with zinc, will zinc react with the diluted sulfuric acid means H2SO4, zinc means Zn. When Zn and H2SO4 will react, then reaction will be occurred, and here will be a gas will be formed, yeah, H2 gas. So for the escaping of the gas, we have provided here a glass tube, and the gas will be go out from the flask. Here the activity 1.3. Take a few zinc granules in a conical test tube, add dilute sulfuric acid. Take a lead nitrate solution in a test tube, add potassium iodide solution. Means that by these reactions we can say that there is the, we can say by the observation whether a chemical reaction had taken place. First, change in the state means if we take the zinc granules react with the dilute sulfuric acid and form the H2SO4 gas. Here we taken the liquid dilute sulfuric acid and the zinc is the granules forms, and the here form the gas H2 gas. That is the gaseous form, means then the state had been changed. We can see here the state change means solid, liquid or gas. Change in color. In the case of lead nitrate and the potassium iodide reactions, here the color becomes the changes. In the evolution of gas means exit out of the gas, means after the reaction they produce the gas. So here H2 gas is produced. Or change in the temperature. In this flask, if we touch the reaction, after the reaction the conical flask become heated. So we can say the reactions had been performed, means that if the reaction will be performed, the first either change in the state of the reactions product, then change in the color, and the solute colors will be converted in the after the reaction. Yeah, evolution of gases. Here H2 gases comes out. Change in the temperature means that the flask where we are performing the reactions, it will also changes. The temperature become changes. Either it will be higher exothermic reaction or endothermic reactions. The chemical equations. Next one is the chemical equations, means that to which reaction we are doing, we are taking the long name. Without symbols it will be difficult to see how the what compound is changed and what will be react. So left hand side is always means that which substance we take for the reaction, that is the reactants, and after the reactions which produced, that is the product. Means at the left hand side we always take the reactants, and the right hand side always we take the product. Means reacted, here we have taken the magnesium, Mg and oxygen. These are reactants. If react and it produce magnesium oxide in the powder form, in the first activity we have seen the substance that undergoes chemical changes in the reaction. 1.1, magnesium and oxygen are in the reactant. The new substance magnesium oxide formed during the reaction as product. There are some symbols which can use. Here we have used the two substances, means magnesium and oxygen. We are combining, means we are doing the reaction. So we have used two products, hence we have add the two, magnesium plus oxygen with the plus sign. And the right hand side, if there are single products, there we will no need of any plus sign. If there is a product more than one, then we will use also the plus sign in there the side of the product side. And arrow shows the direction of the reaction, so from which direction to reaction is going to other directions. So here the reactions is going from the reactant side to the product side. We can see the it is going towards the reactant side to the product side. Next, writing a chemical equation. So in the text form it is difficult to remember the reactions, so we have used the symbolic form. So here we have taken the symbolic form is the easy to write out. The chemical equation represents a chemical reaction. So if you recall formulae of magnesium, oxygen and magnesium oxide, the above word equation can be written as. The word equations which we have used earlier in 1.1, we have converted it in the symbolic form. So here Mg plus O2 react to form the magnesium oxide. Count and compare the number of atoms substituted on the reference side of the arrow. So we have count. The first is the balance of the reaction. So how we will balance the reaction means that the number of the atoms at the product side should be equal to the reactant side. Reactant side and a product side, both sides will be equal number of the atoms. So here we can see in this side one atom of the magnesium, at the reactant side one atom of the magnesium. Here we can see the product side one magnesium oxide atom and plus O2 means here is the two atom of the oxygen, here is only one atom of the oxygen. So we have to, this reaction is the skeletal reaction. Here this reaction is not balanced. So this is the, when the reaction is not balanced, we have only make a general format of the reaction, then reaction is known as the skeletal reaction. This reaction is known as the chemical equation, is a skeletal chemical equation or reaction. So for this we can balance the reaction. So for the balancing the reaction we can multiply 2 here. If we can multiply the Mg with 2 and either and the product side also we can multiply with 2, then it will be balanced. So balance chemical equation will be studied up in next point. 1.1.2 in a balance chemical equation. What is the balance chemical equations means that the number of the atoms at the product sides and the reactant side should be equal. So recall the law of conservation of mass that we studied in class 9. Mass can neither be created nor destroyed in chemical reaction. Means that there will be no loss of any mass, either the reactants or the product. That is the total mass of the elements present in the product of a chemical reaction has to be equal to the total mass of the element present in the reactant. Hence, total mass of the reactant side should be equal to the total mass of the product side. This is the law of conservation of mass. You earlier studied in class 9. The same before and after the chemical reaction. Hence, we need to balance a skeletal chemical equation. So we have need to the balance to the skeletal equation is the chemical equation 1.2 balance. Let us learn about balancing a chemical equation. So here we are going to learn how we can balance the chemical equation. First, zinc plus sulfuric acid. In the activity we have seen 1.3, the zinc plus sulfate plus hydrogen means we have taken the zinc and react with the dilute sulfuric acid and form the zinc sulfate and the hydrogen in the form of the gas. So let us examine the number of the atoms on the both sides, at the reactant side left hand side and the product side the right hand side. Here we can see either at the reactant side zinc atom is 1, and the product side right hand side zinc atom is also single, and when we take the hydrogen atoms, at the hydrogen atoms at the reactant side hydrogen atoms is 2, and the product side also the hydrogen atoms is 2. Next element sulfur. Sulfur is in a H2SO4 only single, and the zinc sulfate also the single. And when we take the oxygen element, oxygen in the left hand side it is 4 atoms, and also in zinc sulfate oxygen is also the 4 atoms. Means that the both reactant sides and product sides both are balanced. Hence here we have no need of the any balancing to the equation. Means it already balanced equation. If not balanced, we can try to balance the reactions by multiplying on the both sides to respective number of the elements. Let's try to balance the following chemical equation: Fe plus H2O. Here is given the iron plus H2O, ferric oxide plus H2. Step 1, how we will balance? First step, to balance a chemical equation, first draw boxes. So here we can draw the boxes in iron H2O, Fe3O4 and plus H2. Second step is list the number of atoms of the different elements present in the unbalanced equation, where in skeletal equations. Unbalanced equation are in the skeletal equations. We have taken the atoms iron, hydrogen and oxygen, the number of atoms in reactants. In left hand side, iron is first, hydrogen is second, 2 atoms, and the oxygen have 1 atom. And the product side, at the right hand side, here we can see the iron has 3 atoms, oxygen have second is hydrogen. Hydrogen has 2 atoms and the oxygen has 4 atoms. Either the at the side of the product. Step 3. It is often convenient to start balancing with the compound that contains the maximum number of atoms. Means that it will be more suitable, we can deal with the compound with the maximum number of atoms. It may be a reactant or a product. Either it will be reactant or the product. We can see which have maximum atoms. We will start from there. In that compound, select the element which has the maximum number of atoms. In this case, Fe3O4 have the maximum number of the atoms and the element oxygen in it. Means oxygen has the more atoms, maximum number of atoms 4. Here we can see oxygen have the more atoms in comparison to other elements. So we are going to balance firstly the number of the oxygen. So here to balance an initial. In H2O only 1 oxygen, in the Fe3O4 there are 4 oxygen. So we should multiply with 4 in H2O. Every multiplication multiplication will be performed out of the box. So here we can see we are multiplying with the 4 H2O. In the equation 1.6 we are this is the partially balanced equation. Means further we have it should be balanced. Step 4. Iron and hydrogen atoms are all still not balanced. Means if we can see, so here iron and the hydrogen are not balanced in question. Here is the 4H2O. When we have multiplied with the 4 in H2O, so here it become the 8 hydrogen, and here only 2 hydrogen. So for this we can multiply it with 4 at the H2O. Here is the 8. So here 2 atom of H2. Hence we have multiplied with the 4 to become 8. Here we have multiplied with 4. Now the number of the hydrogen at the reactant side is 8, and the also product side 8. A number of oxygen 4 is as a reactant side, number of oxygen at the product side. Both are balanced. Or only it is also partially balanced equation because iron have remained unbalanced. So further we will examine. So here iron is the 3 atoms, iron have 3 atoms, and here iron have only 1 atom. That's the reason we will multiply with 3 in the iron at the reactant side. And after the reacting this, multiply with this, it become the atoms have been balance of the reactant side and the product side. We can count 3 iron at the reactant side, 3 iron in the product side. Here 4 2 ja 8 hydrogen at the reactant side and 4 2 ja 8 hydrogen at the product side. Hydrogen have balance, oxygen have balance, and now we can see the iron. It is 3 Fe at the reactant side and 3 Fe also the product side. Hence we can say the reaction has balance. Now we will finally check the correctness of the balance equation. We count atoms, and this is the balance equation. We have removed the box and multiply with the equation, and equations have been balanced. Next one is the writing symbols of physical state. The reaction have been balanced, but problem is that here we cannot find out the iron in the solid state or in gaseous state, H2 in the liquid state or gaseous state. For this purpose, we have to symbolize to this substance. So for the liquid, we use the small l in notation in the bracket, and the gas, for the gas we use the small g, and for solid we use small s. So here after providing the physical state in the boxes, now we rewrite the equation 1.103 Fe solid plus 4H2. Here Fe34 is a solid and 4H2 is the gaseous state. So note the symbol G is used in the with H2O to indicate that the reaction water is used in the form of steam. So here is the gas. Gas means H2O is a gaseous form, means we have taken the hot water in the vapor. Usually physical states are not included in the chemical equation unless it is necessary to specify them. So whenever we have necessary to give the state of equation, we will use, otherwise it is not necessary to write them. Next equation we can see reaction with carbon monoxide gas phase 2H2 gas at the 340 atmospheric equation. Means these are the reaction conditions. So temperature, pressure, catalyst, etc. for the reaction are indicated above and are below. This is the rules. Whenever we have necessary to give the conditions, the reactions will be occurred in the specific condition, either in the form of the temperature, pressure, or catalyst, etc. For the reaction are the indicated above and are below the arrow in the equation. Here we have provided the 340 atmosphere, means we have the need of the pressure, atmospheric pressure of 340 atmosphere. Only then the reaction will be performed. Then CO gas plus 2H2, if when react at the 340 atmospheric condition pressure, it will convert in the CH3OH. Next one is the 6CO2 in the aqueous, means the reaction are performing in the water medium, and H2O liquid, the sunlight and chlorophyll, it form the C6H12OX is glucose plus 6O2 plus 6H2O. This is the reaction of the photosynthesis. We have already studied the photosynthesis in the science in the previous class. This is the reaction of photosynthesis. So it is necessary to understood. The chapters are finished, and the questions I have given, so you can try for the question answers. And in the next class we will discuss the second chapter of the chemistry. So please revise the topic, and the board exam is coming soon, so perform the best in the examination of the revision. You can try to do balancing of the equations also. Thank you for watching. Dhanyavad.